Yeah, well, these are called hyperbolic functions. Uma unalo sign ogcina ngo-H, you can call it hyperbolic sign. Cos ogcina ngo-H, hyperbolic cos, hyperbolic tangent, hyperbolic cosec, hyperbolic sec, hyperbolic cot, ne? Or lo H lona ekugcineni sounda like CH. So when you call this, you can call it cinch. Okay? It's like, imagine going to CH. It's sign, but with a CH ekugcineni. This one they call it cosh. Okay? This will be tanch, cosech, secant, and coach. Yabani it isn't jal. Alright, but there'll be the chi thingy. No H, or else you can just say hyperbolic sign. Alright. Now the E, you already know is that number 2.71. When you raise it to the power of x, uti minus e to the power of negative x, or must it divide by 2? Or another way to write it, to simplify it, is simply to write half, open bracket, e to the x minus e to the negative x. You close the bracket. It's one and the same thing. That's why they put a 2 la. The difference ukuthi leyaga cinch, it has a minus. Kosh in a plus lana. There is something what we say odd function, na even function. Well, you don't need this. I'm just passing through. You don't need them for my derivative. Okay? You need this if you're doing identities. Simplify, you know, like how you used to simplify, you need the trig identities. Alright, so these are definition of hyperbolic functions. They are basically more or less like the same. Look at the tangent, tang. You expect it to be sine, sinh over cosh. Can you see? Like sine over cos. If it was cosec, it would be 1 over sine. You see, cosec over 1 over sinh. Basically the same thing. The only definition, ilega sine, sinh, no cosh. It's been defined differently. That's all. Alright. Alright, then the next thing we go to their identities, hyperbolic identities. Well, this one, it looks like pretty the same. When you had sine of a negative x, you will write it the same as negative sine of x. We good, ne? Alright. We know it does that with sine. With cosh or cos, you know you ignore it. So it's pretty much the same. Now, what's different now, it's this. What you know if you had a plus here, cos squared plus sine squared is a 1. Can you see? But then you also had double angles last time. One of the double angle you got cos 2, it will be cos squared minus sine squared. The one we normally say, don't make a mistake and say it's a 1 or a negative 1. This time it does. It becomes a 1 because it's now cosh squared minus sinh squared. So it's a 1. It's just an identity. Alright. And then from this you can get this one of the other one for for tanh, cos. All right, this is like a compound. With the compound, when you got sine of x plus y, it becomes sine cos, sine cos. The sign stays the same, so it's basically the same. Can you see that? Lana, hey, kosh, it's slightly different now. You see, the sign was supposed to change in another one. In this one, it does not change. But this is just for I'ma prove none. All right, but then here we go. This is now the derivatives. They pretty look much the same as the other one. But the only difference is the other one we knew everything that had a C, starting with the C. Helps me to remember the C means change the sign. All right, or you must have a negative there. So in this case, what's happening? The basic three trigonometry, they are the one who become positive, like sine, cos, tangent. They are always positive. The derivative looks like the one of value, sine, cos, tan, exactly match. But this time, anything that is a C, it doesn't have to change. But the basic one, sine, cos, tan, positive. So sinh, cos, tang, they are positive. We know that the one of sine must be cos. The one of cos becomes sinh. Of tang becomes sec squared. All right, but now I'm going to add here, because here they're using the x. We are supposed to add and say times by dx, the derivative of that angle, over dx. So you know these textbooks, they don't show that, which is 1. We're good, né? All of them, dx times dx over dx. All of them times dx over dx. All right, so which means now these are just hyperbolic functions, or we can say hyperbolic trig functions. We haven't done the arc. The arc will be these ones, the one with the minus. They call them inverse, which is arc. The arc hyperbolic function, they look exactly like the one, the trig, exactly. La, it's not 1. We know you had to say dx over dx since they're using the x, and which is 1. We good, ne? Yeah. So normally what we do, if we're to put a u in place of x, right here I'll say du over dx, exactly like the previous one. And then what we need to do, Manch, is just to apply them. So we got 2. These are the hyperbolic functions direct. These are the inverse. So you see, if you know the rule, now you know how to derive. Can you see? You just have to walk or to tread carefully. Don't forget how you derive. All right, here's an example. They say find the derivative. Simplify where possible. So we're having this one here. Now, the first thing, I'm going to just go slowly so that it helps you remember even the other ones. You got f of x equals to, it's actually e to the x. I'll put a dot there, then and say times by cos of x. I color-coded them so that you can see it's a product rule first and foremost. So all the rules, the quotient, the product, the power, implicit, those four, they go everywhere. All right? Here you just know how to derive, but there will be those normal rules. So when we derive this one, f prime x equals to, well, if you want to, you can call this one u, you can call this one v. Ne? You know, okay, let me rather do that. Let me rather do that so that you can remember the rule. It shouldn't look like, hey, this is complicated. I'm gonna call this one u times by the v. So now if I do the derivative of f prime x equals to, the first thing, you stop the first, or you can derive it, choice is yours. All right, so I would stop the first, then derive the second, then I would say plus, I derive the first, I stop the second. This is me reminding you the rule. Now you apply it. All right, so now we write the derivative f prime x equals to, the u, it's e to the x, so don't derive it, leave it alone. So we'll write it as e to the x times, then I need to derive the v, this one cosh here. Can you see that? Then I go look at its rule, just for the yellow part, which is this one. It becomes sinh x. Can you see? All right. So then we come there, we write sinh of x. It's this part. Then you say plus. Plus. Now you want to derive the e to the x. Well, we know e to the x by now, we might have memorized it. It remains the same. But in a true sense of it, you need to say it's e to the x, and then you need to times it by the derivative of the exponent, all right? And then you do the ln of the base, remember? Yeah. All right, so once it remains the same. So it will be e to the x, and then the second one you keep it as it is, then it becomes cosh of x. So now you have derived it, it's done.